Hi, good day. This is Danife Luis E. Oliveros, and I will be presenting my assignment number 2 in CMSC 203, Computer Systems and Organization. Starting off with Module 7, it will be Abstract Data Types. And the first abstract data types are sets, which are high-level abstract data type involving the operations inserting, deleting, and checking for membership. These enumerated types are used with equates to be implemented. Equates defines a value that the assembler can use to substitute in other instructions. And the equates will be enumerated types are mapped as equates in multiples of 2. This is to assign a certain bit position to a certain set value. Example will be this. To insert an element into the set, its associated bit is simply activated, like this example. And deleting will be the vice versa, which is to deactivate its associated bit, like this. Testing for the element will look like this. And the next data type are arrays, which provide substantial expansion. Arrays are structured data type that contains elements of similar types, and its individual items are accessed through the index that specifies their location in the array. Example to the Pascal is like this one. And example to the ASM is this. There are 3 methods to access an element in an array. First is register indirection. In this code, we have to understand that mu takes a second operand and register AX, and it leaves the result in AX. The second one is by using base addressing, in which similarly we consider item size and I is in the previous section. The statement array I can be translated as follows. And for the base index addressing, it is translated into this. The last data type are records, which are structured data type whose items are of different data types. Since each item belongs to a particular field, they are accessed uniquely, which makes them distinguishing from one another. And translating it to ASM will give this example. Declaring the record variable which only appears as contiguous bytes. And accessing it will require this example. Now moving to Module 8 is Advanced Manipulations, which tackled techniques that are often used to optimize assembly language programming. First of the technique is memory mapped data controls, which are the areas in the main memory that contains values that should be controlled so that corresponding devices will be controlled. Most popular of which is B800H, that corresponds to the text mode video screen, and placing certain data with it will immediately show changes on the screen. Example of manipulating B800H is this one. Segment 0040H contains values that determine the existence and status of a lot of other devices. Other popular location address are 10H, known for equipment list, 1AH, 1EH, 1CH is known for keyboard buffer, head and tail, 3EH to 42H is for diskette controller status, 49H to 66H is known to manipulate video controller information. Another technique is direct port access, and ports are mechanisms that connect the CPU to other devices. Data on ports can be located on a specific port address, where usually is written with in and out instructions. In instruction is for data coming from port transferred to a register AL, which is the only register used for port data transfers. There are two ways to specify port address. It can be written together with the instruction like this one, or placing it in data register. And these are commonly known port addresses. Like for the system timer, it will be under port address 040H, 05FH. Hard disk controller is on port address 1F0H to 1FH or 320H to 32FH. Game controller adapter is from port 200H to 207H. VGA card is from 3C0H to 3CFH and or 300H to 307H. Floppy disk controller is from 3F0H to 3F7H. Serial port 1, COM1 is from port address 3F8H to 3FFH. Serial port 2, COM2 is from 3F8H to 3FFH. And the parallel port 1, LPT1, is from port 3BCH to 3BFH. Moving on to Module 9, we will be knowing the definition of an operating system. First on the list is the functions of an operating system. To understand this, let's look at one of the first computers, the IBM PC. So when the power is turned on, the instruction register is set to a fixed value by the internal hardware. Inside the CPU. The CPU then starts to execute the program in the address. This program is permanently etched in the memory chip called read-only memory and is executed there, which tells to load it in from the floppy disk using a more elaborate program called Disk Operating System. The DOS then controls the screen and keyboard and permits other programs to be loaded into the memory at your command. Once DOS is loaded, it acts as interface between the user and the computer, which is the main function of an operating system. To fully understand the functions, these are the detailed functions and definitions and functions of an operating system. So it will be a set of procedures for driving the resources of the system. It is a program implemented in either firmware or software which acts as an interface between the user of a computer and the computer hardware. If a computer has no operating system, a user who wants to run a program that uses some of the resources of the system will need to write a program that includes codes for driving the resources of the system. Example, keyboard, printers, etc., aside from the codes for the actual problem the user wants to solve. And it allows several users to start the system. Main of the objectives of which are to provide a convenient environment for the development and execution of programs, to schedule computational activities to ensure good performance of the computing system. Concrete services offered that OS provides are one, convenient input or output operations. This usually users do not want to know the details of how a particular peripheral has to be driven in order to read or print a character. A higher level interface this is provided by the OS. Second service is fault monitoring. The operating system provides a scheme to proceed to the next program if an error occurs in the program currently running. The OS also provides error messages to help the user find the errors in the program. Third is multi-access, allowing several users to use the system is more convenient than waiting for one user to finish before the next is allowed to use the system. Fourth service is file system. The OS maintains a file directory and security of a user's file. This is necessary especially if you allow several users to use the system. Thanks to the operating system, a computer becomes a user-friendly interface. So let's now look at its evolution. When computers were first built, they were fitted with a fairly elaborate control console which allowed its operation to be monitored. Many lights and keys were enabled to perform alterations to instructions, and the control of a programmer is necessary as use is instruction by instruction via punch cards or punch paper tapes, which are then monitored for testing and amending until the program executes correctly. Hence, operating systems during those days were a single user and interactive. Since use of PC then means directly programming it in machine language, most computers then were provided with additional software and hardware such as assemblers, loaders, and linkers, and libraries for common functions. Card readers, line printers, and magnetic tapes then became of common use. And in pursuit of making program development be convenient, language translators were invented. However, computer operations became more complex, considering the to and from operations of translators. Attempts were made to reduce the time spent for a job setup, like hiring professional operator. As a result, automatic job sequencing and program loading were introduced. And this is done via creating a supervisor program that understood job control language that contains instructions where to read the compilers, linkers, and loaders. This then formed the core of batch operating systems. In this system, or an inexpensive processor is used to input by transferring data and programs from card readers to magnetic tapes. These input tapes are transferred to the main computer where processing occurs. Most of the batch systems may render CPU idle most of the time, and the solution to this is multi-programming. The idea of which is to divide the memory into several partitions, and programs are then loaded when the other programs is not using the system. Simultaneous to the demands to multi-programming, time sharing was introduced as a result for demands to use convenience. The user then is given a certain amount of time and then will give the control of CPU to another user after a time. Further PC development paved way for personal computers and workstations, which introduced network operating system that allow personal computers to access resources which are not local to them. Hence, this is the operating system's variation used today and are very helpful for multi-data processing. Moving on to Module 10 is the basic operating system concepts. So what is a process? Process is a unique execution of a program with a specific set of data. Don't confuse process with a program, as the program is a software, and when it is loaded, it becomes a process. First of the basic is interrupt, which is an event that causes the normal execution of instruction to be altered. Examples of interrupt are 1. Completion of an input-output operation. 2. Errors in the process being executed. 3. Arrival of messages from another system. And 4. Arrival of data from input or output devices. So, in handling interrupts, we must first provide an interrupt line. 2. Modify the microcode of the fetch, decode, execute cycle of the CPU. And 3. Include the necessary device handlers either in the OS or in the applications program. Usually, when a device needs to interrupt the CPU, it sends an interrupt signal over the bus, usually called control signal, which is sent to the CPU. Once CPU receives it, it interprets this control signal as an interrupt coming from a device, which is called interrupt line. That is a line of communication between the device causing the interrupt and the CPU. Moving on to the next concept are device drivers. And device drivers are low-level program written specifically to control a device. And this is an example of a device driver for catching data coming in at the data port COM1. The procedure BIOS COM is a DOS procedure that makes various communications over the input-output port given in port. The first parameter indicates the command. The second parameter is used to indicate the parameters of the command, which is useful for the command that set the communication parameters. And the third parameter is the port indicator, which is 0 for COM1 and 1 for COM2. The next is supervisor calls. The memory is usually divided into two areas, namely systems area, where all the system's codes are loaded, and the users area, where users' programs are loaded. And supervisor calls is an instruction which contains information on the request, which allows the user to access parts of the system's area. When a supervisor call is executed, it causes an interrupt. The OS examines the instruction to be executed and checks if a supervisor call has occurred. The OS executes the system's code requested and returns to the instruction following the supervisor code. Modes of execution. Operating system must know to distinguish systems processes that can never be interrupted from the processes that can be interrupted. This is achieved through a bit in the program status word, which when set to 0 is set to be on a supervisor mode or interrupt disabled mode, and when set to 1 is in user mode or interrupt enabled mode. A next concept is multiprogramming, which is a technique of allowing several user processes to run at the same time. To support this, context switching, or a way of switching processes, is needed. This is done by saving the state of computations of the process so that resume to the execution is possible once control is back to the CPU. State of computation or context of the process is given by the current values of one program counter. It states where are we in the process. Second value is register. States where control information and other intermediate values of the computation of the process are stored. And third values will be flags and other information used by the process. Buffering, on the other hand, are attempts to keep both the CPU and input or output devices busy all the time through the use of a piece of memory used for storing this unprocessed data called a buffer. Spooling then is the process of input-output procedures executing a transfer to some intermediate medium such as a disk instead of transferring directly to the device associated with the process stream. And last concept is time sharing systems, which is the CPU is rotated among the users of the system, each given a particular same time to process their activity. An aid of a hardware clock that generates an interrupt when a process consumes its time share is needed for this. And that will be for Module 10. Moving on to Module 11 is processor management. First is we need the process to be created, and it is done via the operating system creates a PCB for the said process and appends this to list of existing PCBs in the system. Once process is created, it can stay in the ready, run, or black states. And the ready state is a state wherein it is ready to take control of the CPU. Run state is currently in the control of the CPU, and black state is waiting for an event to happen. Reasons for a process to be blocked are: one, if it is waiting for an input or output completion; two, if it is waiting for a particular time of day; and three, if it is waiting for a message from another process. Other transitions equated with these transitions are dispatch. I'm sorry for the number two, but that will only be block without ed. So I'm sorry for that. And number three, wake up for preempt. So dispatch is the transition from ready to run. This is the assignment of the CPU to the process determined by the system to be the most suitable to continue. Block is transition from run to blocked, happens when a process voluntarily relinquishes control of the CPU due to some requirements that may not be available immediately. Wake up is transition from blocked to ready. This happens when the task that the process is waiting to occur happens. Preempt transition from run to ready and happens when a process is forced out of the CPU because a higher priority job is ready to take control of the CPU. Next, in the process management is process termination. And the two kinds are normal termination, which is a call by the process to a termination state, and the abnormal termination, which is a forced termination of the process by the operating system due to some unrecoverable error. This is when the process is terminated, the OS deletes the PCB of the process to free the space. CPU scheduling is to allocate the CPU in order to optimize system performance without sacrificing user convenience. To implement this, a dispatcher is needed and is responsible for allocating the CPU among various processes in the system. Specifically, it is asking job scheduler for the process most suitable to take control of the CPU. This CPU scheduling has two kinds, which are short-term scheduler and long-term scheduler. Moving on to module 12 is the memory management. In early systems, memory management or most of memory managers implicitly allocated all the memory to a user process, which created problems like user process accessing area occupied by operating system which may delete it. Then came multi-programming systems, which enhanced the memory manager to one where it allows several processes to occupy the memory at the same time. And since this system encounters a number of processes being blocked, different memory management schemes were introduced. One of the schemes were fixed number of tasks is loaded in memory, and another is allowing a variable number of tasks. A memory management and time sharing system came, and although this is very user friendly, Several user processes are running, but not all of them will fit in the memory. A resolution to this is swapping was introduced, and um, it is done by writing the core image of the process in memory to the backing store and the core image of the higher priority process read in. Another aspect of memory management is memory protection. Usual approach to protect processes in memory is to separate the operating system from the user processes, allowing only a user to process its own address space while allowing the OS to access any memory location to the memory. Implementations of this are many, but they are classified into three, which are automatic address translation, page 0 to page 1 addressing, and use of base and limit registers. Virtual addressing or address assumed by user from real address that is used with translation for fetching of the instruction. The virtual address is compared with the content of the limit register, and if it does not exceed the value in the limit register, then it is added to the contents of the base register to get the real address. If, on the other hand, the value of the virtual address exceeds that of the limit register, then an address error will be issued by the system. The value of the base and limit addresses is kept for each process in their corresponding PCBs. These values are available to the CPU because they were restored to their corresponding registers when the process took control of the CPU. Last module will be in module 13, and it will be for file management. And what is a file? It is a uniform logical view of a contiguous set of words, data, or instruction. For a file system to be desirable, it should provide high-level operations on files, protect files from users who do not own them, be reliable, and provide fast access to files. File directory is a storage of a file descriptor, which is a set of information like 1. Name of the file, 2. Location on secondary storage, 3. Length of the file, 4. Type of access allowed, 5. Owner of the file, and 6. Date of creation or modification. In detail, it is some sort of a symbol table which translates file names into their directory entries. Several operations can be done on the entries of a directory. They are search for an entry, create an entry, delete an entry, change the name field of the file descriptor. The basic operations on files are creating a file, 2. Write to a file, 3. Read from a file, 4. Rewind the file, and 5. Delete a file, which are then done from the system call. Other necessary operations, namely appending information at the end of the file, modifying contents of a file, copying the contents of a file to another, renaming a file, listing the contents of a file to an output device, and these are done on the utilities of the operating system. More efficiently if it can detect whether a file is currently being used, so additional operations open and close are needed. Open operation informs the system that the file is about to become active, and close informs the file is about to become inactive. File system protection is limiting the type of file access, and it depends on the type of access requested. The operations that can be controlled are read, write, execute, append, and delete. And it depends on the type, or I'm sorry, this controlled operations when disabling access to other users will only give the read access, making your file more secure. Implementations of this will be put actions such as file naming, passwords, and access control. File naming is achievable by allowing only users to see the files they have created. Passwords, as we know, are encrypting a password and accessing the file. And access control is an access list of the type of users that can access the file. Two types of access are sequential access and direct access. The sequential access is the file is accessed in sequence, and direct access is any record in the file can be accessed without restriction to what has been accessed earlier. File allocation methods. The methods are contiguous allocation method, linked allocation method, and index allocation method. File system reliability. Reliability of a file is in usual ways by making duplicates or even more copies of files. These are periodic dump and incremental dump, or that will be the most usual way of doing dumps. Periodic dump, all files in the system are copied to another device, usually a magnetic tape. And incremental dump, all files that get modified from the last dump are written to another device. This is faster and is usually done more often. These dumps are possible to lose some data happens when the system crashes just before a dump is made. So transaction logging is then used, which is every transaction received by the system is dumped. If system fails, the dumped transactions are run through previously dumped files. This concludes the my presentation for modules 7 to 13. Hope it is clear. Thank you very much. Have a great day.